Now, up until this point, we've basically just been considering how an individual data point or observation can impact our estimated coefficients. That's really what we've been concerned about. And we've been concerned about how an observation that's an outlier with regard to x's, right, with high leverage, or with regard to y, studentized residuals, that's still how they impact the estimated coefficients. Now, it's possible, however, though, if we have many covariates, that data points could have a joint influence on the fitted model in the sense that they're outliers in our cloud of x's again. So there's some graphical methods that we can use to help identify these subsets of data points that may be jointly influential. And so for this purpose, we're going to go back to something that we talked about in previous modules, and that's the partial regression plot or the added variable plot. And just to give you kind of a reminder of how we're going to construct this is first we're going to compute the residuals of regressing our response variable y against all independent variables except for each one. So we'll start with the first and we'll omit the first and run our regression with variable or covariates 2 and 3, let's say. Now, then we compute the residuals from regressing our covariate 1 against all of the other independent variables, so against 2 and 3. And again, we're doing this for all combinations of the covariates. Then what we're going to do is plot the residuals from the first part against the residuals from the second part. And what this is going to do is this is going to provide us information on how adding that first covariate to the model impacts the fitted regression. After we fit the regression to this plot, we're going to add in a fitted line. The residuals are going to be the same as the full model from the multiple regression residuals. And again, you should see a linear relationship in the partial regression plot. What we're going to be interested in here is looking for outliers that appear outside of the cloud of x's in these added variable plots. So, as an example, what we're going to do is we're going to go back to using the Duncan dataset, where we're interested in the level of perceived prestige of occupations from an opinion survey in the 1950s. And again, what we're interested in here is seeing whether or not minister was influential, because that's something that we found to be influential in impacting our coefficients, right? It had high leverage and it also had high studentized residuals. So we want to check, does it have high joint influence? Because it also had an odd combination of income and education, where there is low income for the field, but high education. So it had high leverage. So again, we had noted that minister was highly influential. Let's just see whether or not that's jointly influential by estimating a model with and without this data point. And then we'll look at the partial regression plots. So we'll start off. We're just going to estimate our first regression normally with everything in it and our two variables of interest, education and income. Then we're going to regress without minister. Now you can see here I'm just taking that observation out, which happened to be the 6th row. Now when we go to construct our added variable plot, we just plug in what our first full model was and do AV for added variable plot. And here what we're telling it is what the added variable we want is. So again, conditional on leaving education out and then including it, and then looking at the partial effect, we can see that there is a linear relationship, so that's positive here. But what's more important is that we can see that minister and conductor are in fact quite far away from the cloud of x's, which again is concerning. So we're finding exactly what we had saw before, but now we can be more rest assured that minister is something that is not only highly influential, but it may be jointly influential. So it's highly influential across many of our variables. Now, we can do this again with income. And again, we can see that though there is a linear relationship, both conductor and minister tend to fall outside the cloud of x's, which again indicates that not only did we find that they were highly influential and had high leverage, as well as studentized residuals, they seem to have large joint influence in the sense of having those characteristics across multiple variables. To sum up, plot 1 was showing the education coefficient from our multiple regression. This estimated coefficient for education is higher when minister is included. We can see that again, and I'll go back for a second. We can see that because, again, it's going to be higher because it's pulling that fitted line toward it. It's pulling it up. Now, the conductor data point influences the fitted line in the same direction in that instance, again, because it's tilting the regression line toward a steeper slope, right? So it's increasing our estimated coefficient. So if we remove both of these observations at once, we may end up having a very large change in our estimate for education. Now with the second plot, we can see that minister and conductor work together to flatten the income multiple regression coefficient. Now if we remove both of those at once, it'll still show a large change, but again, it's going to flatten or decrease the slope of that line. In sum, outliers and looking for outliers to see how they impact your estimates is really important. And they may indicate that there's just some peculiarity with your sample, or it may actually indicate that you have some error in your data. And this is a really good way of checking to see if that's the case. It may also suggest that the observation belongs to, quote, another population or a different data generating process, right? And so that is problematic in the sense that our model and the sample that we have may not actually be a good representation of the true population at hand. So fitting a model with and without an observation is going to give you a better sense or feel for how your model and the estimates that you get are going to be sensitive and change based on whether or not that observation is included. And again, I cannot stress that the biggest takeaway is that just checking and documenting this is really informative for you and your readers as to what you are able to glean from the data that you actually have.